In this video, we're going to talk about angle bisectors and the angle bisector theorem. So angle bisector theorem says if a point is on a bisector of an angle, then the point is equidistant from the sides. So we have AD bisects angle ABC, angle BAC, excuse me. That means we have two congruent angles. And that also means that if you draw perpendicular segments, so you choose a point on the bisector and draw a perpendicular, that's key, to the sides of the angle, then those two segments are congruent. So BD would be congruent to CD. For the converse, if you have an angle and you have the point on the inside is equidistant and perpendicular to the sides of the angle, then that means we have an angle bisector. So angle BAD would be congruent to angle CAD. So this allows you to solve for different angles or triangles that are missing. So for number 1, if we want to find the value of x, we know that bisected. We also know that this segment is perpendicular to the sides of the angle, and if you're not really sure about that, you can kind of extend this to see, make it look more like the examples at the top. So if you think about it, if we showed that this side was reflexive property, you'd have angle, angle, side. So because the triangles are congruent, that means those two segments are congruent. So 4x plus 30 equals 9x minus 5. And we'll leave you to finish up the algebra. In number 2, we're wondering if this is a bisector. So we have an angle. Again, you could extend this just so that you can see that it was an angle. And these two segments are perpendicular to the sides and are congruent to each other. And again, if we think of it in terms of congruent triangles, you'd have this side congruent to itself. We have right triangles, so you'd have hypotenuse leg. So according to corresponding parts of congruent triangles, these two angles must be congruent. So 5x minus 11 equals 8x minus 41. And again, solving the algebra is up to you. So go ahead and complete the remainder of this worksheet.